Hello again, my name is Eric. Welcome to Cafe Calculations. And today we're doing our final lesson on axioms. And today this is probably the most common axiom or property that everybody always remembers from school. It's the one that always I can have parents remember and students remember and so forth, but it's the distributive property. Now this does fall into the axioms, but in reality it's kind of a combination of all of them. So it's important to understand these, and it's important that if you can kind of start to see the patterns here, how addition and multiplication, these things hold, division and subtraction, they do not. And as I've mentioned before, addition and multiplication are the same operation, and division and subtraction are the same operation. So really you have two operations here, almost like a duality, a plus and a minus. And in reality, this is kind of the whole premise that sets up for us to infer all mathematics. There's always kind of an inverse operation or an opposite operation or an opposite thing that allows us to unlock the information we want. So anyways, I kind of went off on a little tangent there, but let's look at the distributive property, and let me just state it for what it is in general first thing. The distributive property goes as follows. A, open parenthesis, B plus C, close parenthesis, is equal to A times B plus A times C. Now, in this case, I'm going to use notation without the star for the multiplication. I was using the star for multiplication only because we are kind of swimming around the arithmetic area. But I feel like once we get to the distributive law, we're kind of in the algebra area. So now, if you have two variables or two things next to each other besides numbers, it's inferred that it's multiplication. If they're numbers, usually you'll see a dot, or it'll be in parentheses. This is kind of just grammar and notation of things. Anyways, let's continue on. Therefore, let A equal B, and we're going to let B equal C to show if this thing holds in general. All right, so here we go. A, open parentheses, substitute A for B, we'll put that in parentheses, plus, parentheses again, A, which will substitute A, because if B equals C and B equals A, then A equals C, right? You can remember what property that is. So really we have A once again. Is equal to, let's look at the right side. We bring down the A, well we have a B, but we already said that A equals B. So bring down the A once again, put that in parentheses. Plus A, parentheses, once again, transitive property, A equals B, B equals C, therefore A equals C. And therefore we can say C is equal to A. So now, let's clean it all up and see if it all holds. On the left side, I'm going to do the inside the parentheses first. A plus A, I get 2A. And that is still inside the greater parentheses, which is going to be multiplied to the outside A. So A times 2A is really 2A squared. All right, let's look at the right side. In this case, really we can multiply either one first. So we can go A times A, I get A squared. Plus A times A again, we get another A squared. Well, how many A squareds do we have? A squared plus A squared is 2A squared. Ah, look at that. 2A squared equals 2A squared, check. The distributive property holds in general. Let's look at the distributive property with a specific case now. We'll let A equal 2, B equal 3, and C equal 4. So let me just write it in general first. Let's substitute in our values. 2, parentheses, 3 plus 4, close parentheses, is equal to 2, parentheses, 3, close parentheses, plus 2, open parentheses, 4, close parentheses. Now, it may seem kind of maddening stating that the parentheses and all like that grammatically, and it is. And once you know it, you don't have to do it. But me being a teacher, I've learned that when you first learn these things, to really get the grammar of the math, and there is grammar here, it's good to state it. And I figured out over the Zoom lessons during the pandemic that when I had my students state the problem from their book, because let's say they had a written problem on paper and they weren't sharing with me over Zoom, that they were I realized they were not saying the grammar correctly. And when I held them accountable to it, all of a sudden those problems went out the door and they started making less mistakes. It's an important note to make. Anyways, let's continue on. Let's bring down the 2. Now we go 3 plus 4 is equal to 7. Close parentheses. So now we have 2 parentheses 7. Well, 2 times 7 is 14. Let's go to the right side. Go back. So now we get 2 times 3, we bring down the 6, plus 4 times 2 is 8. All right. 6 plus 8 is 14. Hey, look at that. 14 equals 14. Check. The distributive law holds in this specific case. I hope this made some sense to you guys. I hope things are a little clearer. And I hope you have a greater appreciation for these axioms. And I would recommend going back and reviewing these videos after you've had some time to process it or think about it. And you don't need to spend hours and hours on this stuff. Even when you're driving or riding in the car or on a bus or whatever you may be doing, just kind of ponder these central pillars of axioms and how they give the mathematical power for everything else that's built on top of it. Anyways, thank you very much for listening to Cafe Calculations once again. And remember, enjoy the process.